Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this full CCNA course. I'll include the link in the description. Also, remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. Back near the start of this section, we had a lecture where I covered the common attacks that a hacker will launch against you. And now that I've covered the different security devices that are available, I can wrap up the section with this last lecture where I will cover the mitigation techniques which protect you against those different attacks. And I'll cover them off here in the same order that they were covered in the common attacks lecture. So starting off with malware. To guard against this, anti-malware software should be installed on the host systems. Anti-malware software uses signatures and heuristics to detect malicious software and block it from running. So the way that the signatures work is it looks for known characteristics of known viruses. When it sees them, it will block that file from running. What heuristics does is it's not looking for known signatures of viruses. It's looking for characteristics on a file which are common across other different viruses. So there, the file would be suspicious, and that will again trigger the anti-malware software. So you want to have your anti-malware software running on your corporate host PCs, and also you want controls to be in place there to prevent users from disabling the software. Because maybe a hacker has got a Trojan horse which is available for download online. They've made it look very attractive, and a user could be determined that they really want to download this Trojan horse, which of course is going to do damage. So to prevent users from doing bad things like that, you want to make sure that they're prevented from disabling the anti-malware software. And IPS can also be used to detect and block network traffic containing malware from getting into your organization. Still on malware and also providing protection against phishing and data exfiltration, you can use the Cisco ESA and WSA appliances. The ESA is the email security appliance, and it scans links and attachments in incoming email for malware, phishing attacks, and spam, and it blocks them before they can get to your user's mailbox. There's also the Cisco WSA, which is the web security appliance, and that prevents users from accessing dangerous websites, the kind of places that they would maybe accidentally download a Trojan horse or a worm from. Policies can also be implemented on the ESA and the WSA to prevent sensitive information from being sent out of the organization. So you can configure rules with your policies there about what is sensitive information, and you can block that from being sent out. Policies and procedures should be implemented, for example, about how and what information can be sent or taken outside the company premises. For example, to prevent data exfiltration, you could have a policy that staff are not allowed to have corporate data on USB sticks, because that would be easy to lose in a public place. Security awareness training should also be implemented. So, for example, you should train your staff about the dangers of phishing and tell them that they should not open suspicious emails, that they should call a member of the IT staff to investigate it. Moving on to reconnaissance and social engineering. Low-level reconnaissance, for example, just doing research on Google on the company, and also social engineering can use very low-tech methods to gain information and access to the target organization. Because of that, it's difficult for IT departments to use technical solutions to protect against them. So the way to defend against them is through staff security awareness again. Again, policies and procedures should be implemented to guard against these kind of attacks, and staff should be educated about security concerns. So, for example, they should be made aware that if somebody calls them, that person may not be who they say they are, that they should be very guarded about giving out what could be sensitive information. An IPS can defend against deeper reconnaissance, which uses port and vulnerability scanners. It's not normal behavior for a host to scan through a range of port numbers. That would indicate a port scan attack, and an IPS can detect and drop that traffic. Now, a determined attacker may attempt to circumvent this by running the scan over a longer period of time. That can make it more difficult for the IPS to detect it. But if you're using an advanced IPS, like the one from Cisco, it can still detect this kind of attack because it's able to correlate actions that happen before and after other actions. So if it sees that a host has been running a port scan over a long period of time, and then that host takes another action, which would indicate an escalation of the attack, that will trigger the IPS to fire. It will send an alert to the administrators, and you can also block that host. Moving on to distributed denial of service. Again, we can use an IPS here. An IPS can detect DDoS attacks through anomaly-based inspection. Obviously, if you're under a DDoS attack, it's not going to be conforming to the normal traffic patterns that you would expect to see. Also, advanced firewalls like the Cisco ASA can offload incoming connection attempts from servers when the traffic rate reaches a threshold and respond with quicker connection timeouts and/or cookies. So how this works is if there is a server behind the firewall that you want to protect, the ASA can monitor the rate of traffic, the rate of new connections that are coming into that server. And if it goes above a certain threshold, that would indicate that that server may be under a DDoS attack, and then the firewall can start proxying the incoming connections. So the incoming connections terminate on the firewall rather than the server. And if it is a TCP SYN flood attack, the firewall is capable of actually responding with a cookie rather than a SYN-ACK and not keeping any half-open connections. So the firewall is a hardened security device. It is less susceptible to DDoS attacks than maybe your other servers. However, your firewalls can still be a target of DDoS attacks themselves. They can also become overwhelmed, so there are other solutions available as well. Anti-DDoS services such as Arbor Networks monitor global internet traffic to detect botnets and command and control servers. They have on-premises and cloud-based solutions, so on your premises and also available in the cloud, which scrub traffic when an organization is under DDoS attack. So if you do become under a DDoS attack, with Arbor Networks, they can detect that more easily because they are monitoring for botnets and command and control servers. When it happens, that traffic can be sent either to an appliance on premises or to a cloud-based service, which will scrub it, which will just allow the clean traffic through, and which will block the traffic from the botnet. Geographic dispersion of an organization's services can also help mitigate DDoS attacks. So you can use Anycast to have your servers spread across multiple locations. That makes it more difficult for an attacker to launch a DDoS attack against it. Next up, spoofing, man-in-the-middle, and reflection attacks. First defense we have here is unicast reverse path forwarding, URPF. This guards against spoofed IP addresses because it verifies a source IP address is reachable through the same interface it was received on. So let me explain how this works. You can see in the diagram here, we've got our outside interface on the left, that's fast0/0 on our router, and we've got an external host out on the internet on the left there. Then on the right, we've got our internal server at 192.168.0.10, and the IP address there is 192.168.0.1/24. So if we did a show IP route on this router in the middle here, you would see that we've got a connected route to the 192.168.0.0/24 network on the inside on fast1/0. Our other connected network is going out to the internet on 203.0.113.0/30 on interface fast0/0. And here we've configured a default static route to send all other traffic out to the internet, again going out interface fast 0/0. So here what happens is the host out on the internet, that's an attacker, and they try to send some traffic in with a spoofed IP address looking like they're actually on the inside of the network. So a reason that they would do this is maybe they know that there are security measures on the inside here, which are only going to accept traffic from this network. So they try to spoof it to make it look like they are on that network. So they send in a packet with a source IP address of 192.168.0.100. Well, if you have got unicast reverse path forwarding turned on, which it is by default, the router is going to block that packet, because what it does is it looks and it sees, okay, that packet coming in, it's come in with source address 192.168.0.100 on interface fast 0/0. What the URPF check does is it says, if I was going to send traffic to that IP address, would I send it out that same interface that it came in on? But no, if the router was going to send traffic to 192.168.0.100, it would send it out the fast 1/0 interface, because that has come in on the fast 0/0, a different interface. That indicates that it is invalid. It's a spoofed source IP address, and the router will just drop that packet. When an attacker does spoof their source IP address, they don't receive return traffic, so they do not see the sequence numbers in TCP responses from the target. Going back to the previous slide again, let's say that we didn't have URPF on here, and that the host on the left here did send in a packet with a spoofed source address of 192.168.0.100. Well, whenever return traffic was sent back to the IP address 192.168.0.100, obviously it's not going to get sent back to that host. So when it is sending in traffic with a spoofed source address, that traffic is going to be just one way. It's sending packets into the target. It knows that it's not going to get any return packets coming back. So it's not going to see the sequence numbers in return TCP packets. But a target may be more vulnerable to attacks if it uses predictable TCP sequence numbers. Because the way that TCP works is when a connection is set up and there's a session between two hosts, we're going to use TCP sequence numbers. And if those TCP sequence numbers appear to be invalid, the host will just drop the traffic. Well, going back to the previous slide again, let's say that my host on the left here is sending an attack against the server on the right. And let's say that the traffic is getting to the server. Well, if that server is using predictable TCP sequence numbers, then the host here can pretend like it is in a two-way communication with the server, and it can send multiple packets in that session, and they will be accepted by the server. It would be better if the server used random sequence numbers, and then that would prevent the attacker from doing that. So because of this, your applications should be up to date and patched so that they are using random rather than predictable TCP sequence numbers. If that is not possible, if the application does not support it, then an advanced firewall can also do that as long as it is in the traffic path. Also, to guard against spoofing, you should use secure authentication where possible. Secure authentication proves that systems are communicating with who they think they are. We also have dynamic ARP inspection, which will detect and block ARP spoofing attacks. We covered that back in the switch security section. For guarding against password attacks, firewalls and packet filters, your access control lists, should be configured to prevent illegitimate users from having connectivity to login windows. For example, if you're the administrator and you need to log into a network device to administer it, you should be able to do that. Somebody that works in the warehouse should not have connectivity. They should not be able to get a login prompt on that particular device. If at all possible, that traffic should be blocked. Policies should also be in place to enforce secure passwords for your users who do have a legitimate reason to get to a login window. Password complexity settings include minimum password length, special requirements for the characters, for example, having to use a capital letter, having to use a number, having to use a special character such as an asterisk. Other settings include how often passwords must be changed and prevention of old passwords from being reused again. So what a user might try to do is have a password of password. When they're told to change the password, they change it to something else, but then they just immediately change it again back to password. Your password complexity settings should also prevent that as well. So again, to summarize that, to protect against password attacks, make sure that only people who should be able to get to the login window can get there, and also make sure that your users are using complex passwords. Multi-factor authentication should also be used where suitable. This uses something the user knows, which is their password, and something they have, which could be a biometric reader, for example, something that checks for fingerprint, or a code which is generated on a mobile app or security device. And also, staff should be educated to guard against social engineering attacks against their passwords. So they should be told if somebody phones up and asks for your password or asks to change your password to a certain thing, be very suspicious of that. Do not do it. To guard against buffer overflow attacks, software should be up to date and patched so that it rejects malformed packets. If you've got your own internal developers that are building your own applications, they should also make sure that they are not susceptible to buffer overflow attacks. For packet sniffers, your packet filters and firewalls should be used to ensure traffic paths are controlled. So traffic should only be going where it should be going to. That's going to lessen the chance that somebody that shouldn't see it is able to sniff it. And traffic should be authenticated and encrypted if it passes over an untrusted network. And finally, you can also employ the services of a penetration tester. A penetration tester can be employed to test the organization's security defense. So a penetration tester is a job role. Penetration tester uses the same tools and methods as a hacker. So what we're testing for is, would a hacker be able to do any damage? The way they do that is they act the same way that a hacker would. Internal security teams should also do their own testing of their security systems and policies, but an external penetration tester can be used for validation. Okay, so that was all of the different defense solutions that we're going to use to guard against those threats. See you in the next section. Thanks for watching. If you'd like to get the complete course ad-free right now, then you can click on the link above my head or in the description to enroll in my CCNA Gold Bootcamp. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.